right, not every problem that we have do we have to switch to sines and cosines. As you see this first one, we could just use, for example, the identity of cotangent being 1 over tangent. When we multiply straight across the top, we get tangent of x over tangent of x, which would equal 1. In the second one, I may consider flipping to sines and cosines, cotangent being cosine of x over sine of x. Because it is multiplication, I am able to cross off and cross my fractions here, leaving me with just cosine of x. In the next one, I would first put in the Pythagorean identity. 1 plus tangent squared is secant squared. You can flip those then to their identity, secant squared being 1 over cosine squared x, cosecant 1 over sine squared x, and I can take the top of that fraction times the bottom of that fraction's reciprocal, sine squared x over 1. Multiplying straight across the top, straight across bottom, we get sine squared over cosine squared. And sine over cosine is tangent, so if they were both squared, it would be a tangent squared. On number 4, I would first replace the numerator with our trig identity. 1 minus cosine squared is sine squared. That allows me to cross off one of our sines in the top and bottom, leaving me with a sine of x in the top. Number 5, I would factor out a GCF. And when you factor out a GCF, you have 1 minus cosine squared. 1 minus cosine squared is your Pythagorean identity of sine squared. And that is as simplified as that problem gets. In the next one, it is all addition in the numerator, which means we can add in any order we want, including taking sine squared plus cosine squared first. Well, sine squared plus cosine squared is 1, so then I would have 1 plus tangent squared. Well, 1 plus tangent squared is secant. So I could replace the numerator with secant squared. And we'd be able to simplify a secant out of the numerator and the denominator, leaving us with just secant x. Number 7, I decided to make the top and the bottom both into one fraction. So getting common denominators. Working on that numerator, I had 1 plus sine over cosine, which means I can replace that 1 with a cosine over cosine. And in the bottom, same idea. We had 1 plus cosine over sine. And again, I could replace the 1 with sine over sine, so they have a common denominator of sine over sine. All right, so adding straight across the top, we have cosine x plus sine x over the common denominator. And in the bottom, again, straight across the top, sine x plus cosine x over the common denominator. And now I can take my numerator, which would be here, times the reciprocal of our denominator. And again, multiplying straight across the top, straight across bottom, I am able to cross off the cosine x plus sine x in the top and bottom, leaving me with sine x over cosine x, which simplifies to tangent. Moving on to our next one. These are actually just both Pythagorean identities. That top one comes from the Pythagorean identity of 1 plus tangent squared x equals secant squared x. If I were to solve this for 1, I would subtract tangent squared over, which means 1 would equal secant squared minus tangent squared. So the top of that fraction is 1. The bottom, cosine squared plus sine squared, is just 1, and 1 over 1 is 1. In number 9, I decided to get the inside to be in terms of sines and cosines, so I first rewrote tangent as sine of x over cosine of x, and cotangent as cosine of x over sine of x. The next thing I did is I took that sine of x and I distribute it. So the long route here, it would look like sine of x times the first fraction plus the sine of x times the second fraction, distributing, which would give us a sine squared x over cosine x plus cosine x. And if I wanted to get a common denominator, I would multiply that by cosine x, top and bottom. So now I have a common denominator. I can add straight across the top, keeping it over that common denominator. Well, sine squared plus cosine squared is our Pythagorean identity, so I can replace that with 1. And 1 over cosine I can rewrite as its identity, secant x. Number 10, one of the things we can do is, first of all, replace at the very end here that cosine of pi over 2 minus theta. That is our cofunction identity, and that can be replaced with sine of theta. So this would look like sine of theta minus, and I'm going to go ahead and rewrite that tangent. So this middle term, next term here, tangent cosine, would be sine of theta cosine of theta times cosine of theta. Okay. In that middle term, that is multiplication. Again, order of operations, we would multiply first. Cosine and cosine would cancel there, which would leave us with sine of theta minus sine of theta plus sine of theta. And sine of theta minus sine of theta would be gone, leaving us with just sine theta. Number 11, I went ahead and multiplied out the numerator. Secant minus tangent. Secant times tangent is a difference of squares there. We would get first thing squared minus second thing squared, which again goes back to what we talked about earlier, is one of our Pythagorean identities. Secant squared minus tangent squared is 1. And if we have 1 over secant, that is the same thing as cosine. In the next one, I slid each of those or used its identities to write those in the numerator. So this would be sine squared x, tangent x, plus cosine squared x, tangent x. And they have that GCF of a tangent x, so I factored that out front, leaving me with sine squared x plus cosine squared x. Well, sine squared plus cosine squared I can replace with its Pythagorean identity of 1, which would be tangent x. Number 13, I got a common denominator on this one, so I multiplied by the denominator in the other fraction. First one I would multiply by 1 plus sine x. They are a difference of 2 squares there, so my numerator is just multiplied by 1, so 1 plus sine x. The denominator, 1 plus sine x times 1 minus sine x, is a difference of 2 squares, so we get the first thing squared minus the second thing squared, or FOIL, and you'll get there. In the second one, I would multiply by, again, the other denominator, 1 minus sine x. Okay, so my numerator, 1 minus sine x. Denominator, first thing squared minus second thing squared. So now I can go through and combine my terms in the numerator. 1 plus 1 is 2. Sine minus sine would be gone over the common denominator, which happens to be one of our Pythagorean identities, so I can replace that with cosine squared. And a cosine squared in the bottom is the same thing as, move that to the numerator, 2 secant squared x. Same thing in the next one. I got a common denominator, so I multiplied by secant x plus 1 in that first fraction. which gives me the first thing squared minus the second thing squared. Same thing here, I multiply by secant x minus 1. Which gives me the first thing squared minus the second thing squared. So combining my like terms in the top, secant x plus secant x is 2 secant x. 1 minus 1 is gone over the common denominator. Secant squared x minus 1 is one of our Pythagorean identities, and that is tangent squared. So then at this point I move things to sines and cosines. My numerator of 2 secant x, secant in the numerator is the same thing as a cosine in the denominator. Tangent is sine, so sine squared over cosine squared. And took the numerator times the reciprocal of the denominator. Reciprocal of the denominator. And cosine 1 will simplify, leaving me with this expression, 2 cosine x sine over sine squared x. So there are actually two correct answers that we could see on this one. The first would be if we were to just slide the sine squared to the top and write it as its identity. So that could be 2 cosine x cosecant squared x would be one correct answer. However, a second correct answer comes from manipulating the equation and the fact that sine squared is sine x times sine x, and cosine over sine is cotangent, and then slide that sine up to the top. So it could also be correctly written as 2 cotangent x cosecant x. Number 15, I started by getting a common denominator. I slid the secant down to the bottom, so that first term would be cosine x sine x, which means the second one would need a sine x to have a common denominator. Sine squared. So our numerator becomes 1 minus sine squared x over cosine x sine x. 1 minus sine squared is one of our Pythagorean identities, so cosine squared x. I'm able to cross off one of those cosines, top and bottom, leaving me with cosine x over sine x. And cosine x over sine x is cotangent x. Number 16, again, I did a common denominator on this one, so I multiplied the top, or the first fraction by sine of x, top and bottom, leaving me with sine squared x. I would not distribute in the bottom, leave them just sitting next to each other, because eventually we're going to be able to simplify there. Same thing, multiply by the common denominator, to get the common denominator, 1 minus cosine x is what we're missing. Unfortunately, in the top there, we are going to have to distribute. So we would get here, let's see, 1 minus 2 cosine x plus cosine squared x. Combining my like terms in the numerator is where I would go next, and there's my common denominator. When we combine our like terms, sine squared x plus cosine squared x equals 1, plus the one that was already there is where this 2 is going to come from. That's combining our like terms there. Then I can factor out a GCF of 2 in the numerator. Which allows me to get rid of that 1 minus cosine x. And last thing we would want to do is slide that sine x to the top and make it not a fraction, 2 cosecant x. Number 17, first thing I did was started by rewriting everything in terms of sines and cosines. secant being 1 over cosine x, cotangent, cosine over sine. And that simplifies my first term, again, order of operations, so I would multiply first. I can cross off my cosines top and bottom, and we'd be looking at 1 over sine x minus sine x. So then I would want to get a common denominator. Multiply top and bottom by sine x. And now I can combine my terms here over the common denominator. Replace the 1 minus sine squared with its Pythagorean identity cosine squared. And this is, again, one of those where we can see two correct answers. One thing I could do is just slide the sign up to the top and call this cosine squared x cosecant x. The second is I could rewrite cosine squared as what that actually means, cosine times cosine. And the fact that cosine over sine is cotangent would be a second correct option. One is not better than the other. All right, number 18, the first thing I did is I replaced the denominator, cotangent squared plus 1, with its Pythagorean identity, which is, cosecant squared x. Using the shortcuts or just going long route here, as I slide each of those to the other part of the fraction, secant squared in the numerator is a cosine squared in the denominator. Cosecant squared in the denominator would be a sine squared in the numerator. Sine over cosine is tangent, and if they're both squared, this would be a tangent squared. And our last couple here. In number 19, there's actually a couple like terms. They both have a cotangent, which would be a GCF, so I could pull a cotangent x out to the front. They both have a secant x, which would also be part of the GCF. So if I take a cotangent and a secant out of that first term, you're actually only left with cosecant squared. If I take one cotangent out of that second term, I'd be left with two of them, so cotangent squared, and secant out of there is gone. Well, cosecant minus cotangent is 1, so this would simplify down from its Pythagorean identity. Would simplify down to cotangent x, secant x. If we do explore the sines and cosines of that, that would be a cosine x over sine x times 1 over cosine x, and your cosines would simplify out of there, leaving us with 1 over sine x, which is cosecant x. Our last one, the first thing I did was replace the numerator with its Pythagorean identity. 1 plus tangent squared is secant squared. That allows me to cross off a secant in the numerator and the denominator. And again, I can use their identities to slide them to the other part of the fraction. A secant in the numerator is a cosine in the denominator. Cosecant in the denominator is a sine in the numerator, and sine over cosine is tangent